Right, question 6a, define moment inertia of a rigid body but an axis. You can refer that in our lecture note. It's just basically total I equal to m I r I square. Okay, so explain this in sentences lah. Okay, and then we have been given this diagram. Let me just copy this, screenshot this, copy, and then I'm gonna put this here. Okay, question 6 yang ini. Cantik-cantik dulu dia. Okay, so this is question 6. So apa soalan dia? The figure shows an external force acting on a rod of length 5 meter, which can rotate without friction around its end at point O. So the moment of inertia with respect to point O is 5 kg/m². Determine the angular acceleration of the rod. So they bagi sudah the moment of inertia of the rod. Okay, in this case we are gonna firstly find the moment of inertia of the rod lah. So moment of inertia of the rod is ml². At point O kita sudah dapat 5. We are looking for the mass of the rod dulu. Okay, mass of the rod is not given, so we have to find that value dulu. Square, so mass of the rod is equal to 0.6 kilogram. Okay, and then we can then use the total torque is equal to I alpha. Okay, where we are gonna find the torque for the force F, and then dengan untuk yang the weight of the beam, the rod. Okay, right, so before that let me just draw a diagram, a force diagram. Okay, so this is the value of our force somewhere around here. Boleh lah di sini. Okay, lepas tu center of gravity of the beam or the rod. Boleh lah tu sebelah situ lah kali. Okay, so this is our point O. Okay, this is point O. This is 37 degree. This is force 15 Newton. And then this is the mass of the beam. And then let's us draw the distances. Label the distance. Okay, and then just gonna change it to be a little bit far from the center of gravity. Boleh lah tu. Okay, and then this one is given as well, which is 2 meter. Okay, and then we have to identify berapa this, calculate this distance juga lah. Okay, so this is 0.2 meter, 0.2 pula, 2 meter. The rod berapa length tadi? 5 meter. So this is somewhere around, this is 5 juga lah. So 5 minus 2 is 3. This is 5 meter. 5 pula 2.5 meter, and then 2.5 minus 2 is 0.5 meter. Okay, boleh. Boleh je bah aku nak ni 15 Newton. Okay, so now we are gonna do the torque for the force at point O. Okay, let point O to be the rotation axis. Okay, so torque for the force is 15. Distance there is 2 sine 37 degree, and then sine 37 degree. Lepas tu for the mg lagi, Okay, anti-clockwise. So this is anti-clockwise. So they're positive lah. Okay, distance dia di sini 2 meter. And then for the weight, it is clockwise, so they are negative. Then the distance is this one, which is equal to 2.5 meter. So negative 2.5. Yep. Instead of that, mg dulu. M is equal to 0.6, 9.81. Negative ah. Mg, perpendicular distance dia is 2.5. Okay, dapat ni. Kira dulu lah. So, 15 times 2 times sine 37 degree. Dapat around 18.05 Newton meter. And then this one is negative 0.6, and then 1, 2.5. Around negative 14.7172 Newton meter. Okay, lepas tu substitute lah dalam di atas ni. So 18.05 minus 14.72 equal to I, which is given as berapa tadi? As 5 kilogram meter square. So 5 alpha. So alpha is just 18.05 minus 14.72 divide by 5, which equals to let me write it down dulu lah. 72 divide by 5. You should get the angular acceleration to be equal to 0.666 radian per second square. Okay, so that is the solution for question 6. Sorry, this is a bit tedious, but this is the way you calculate this is the way you solve this type of problem lah. Okay.